Coming up on Philosophy Talk.
There is not one universe. There are many. A multiverse.
The mystery of the multiverse.
There is not one you. There are many. Each of us exists in present time in parallel universes.
Could our universe be just one of an infinite number of universes in the multiverse?
Universes in which there's no matter. Universes in which there's no life. Universes that collapse upon themselves in an instant.
If you imagine scattering around billions of universes out there, with all of these things varying, then you will be lucky somewhere.
Our guest is George Ellis from the University of Cape Town.
That's the basic way that the multiverse is used to explain why our universe allows life to exist.
Are we alone in the space of all universes?
The mystery of the multiverse.
Coming up on Philosophy Talk.
Welcome to Philosophy Talk, the program that questions everything.
Except your intelligence. I'm John Perry.
And I'm Ken Taylor. We're here at the studios of KALW, San Francisco.
We're continuing conversations that begin at Philosopher's Corner at Stanford. That's where Ken teaches philosophy, and I did for 40 years.
40 amazing years, John. Now today, we're thinking about something else amazing, the mystery of the multiverse, another in our series, A Philosophical Guide to the Cosmos.
Well, Ken, in one sense, it seems to me pretty likely that we do live in a multiverse.
Oh, I wouldn't have thought so. I look around and only see one.
Well, just do a little inductive reasoning. Start with the fact that throughout human history, every time we think we know what the universe is, it turns out that there's not just one of those things, but lots of them.
What are you talking about? You mean like when we thought the whole cosmos consisted of basically our own solar system, and then we eventually realized that, there are actually lots of suns just out there just like ours, and that there are lots of solar systems. Is that what you're talking about?
Yeah, if you, at that point, insisted on continuing to identify our solar system with the universe, then you'd have to conclude that we actually live in a multiverse because there's lots of universes.
Yeah, but the mistake was our solar system isn't the entire universe. It's just one solar system among a vast galaxy of stars.
Well, true, but up until the early 20th century, people mistakenly believed that galaxy was everything in the heavens, that the universe was just the Milky Way. But then there's a lot of Milky Ways.
Oh, I guess I kind of see what you're doing, John. I don't really agree with it. You seem to be suggesting that we can conclude by induction that just as it was a mistake for us to identify the total cosmos with our own little solar system and then with our own little galaxy, it's probably just as much a mistake to identify the total cosmos with our own little universe, as we now call it. Is that what you're suggesting?
Exactly. Right. Just as it turns out that there are untold trillions of stars and untold billions of galaxies, maybe there are untold millions of universes.
Yeah, but I don't think this induction works because I think there's a big, huge difference between this multiplicity of solar systems or galaxies and the supposed multiplicity of universe. I don't think the induction works.
Well, I suppose you're right, but you better explain it to me.
Well, because all the many solar systems and all the galaxies are governed by the same laws of physics defined over the same fundamental constants, and those constants have fixed values and relations. As I understand the multiverse hypothesis, that's not so.
So why is that so important?
Well, because it undercuts your induction, because in other universes, in the supposed multiverse, different physical laws pertain and fundamental constants have different values. Maybe in one universe, E equals mc cubed instead of E equals mc squared. Maybe in another universe, light travels at the speed of molasses in our universe. So I don't see how you can get that by anything like induction.
Well, these days I move with the speed of molasses, so maybe that would maybe that would be a good universe for me. But now that you put it that way, I wonder, why in the world or in the universe or perhaps in the multiverse anyone would believe such a thing.
Well, I think the way it goes is it's something like this. I mean, think about the strength of gravity. That's one of those fundamental constants that was presumably set by the way the Big Bang went.
Well, what about the strength of gravity?
Well, so it's like a Goldilocks principle. It's set just at the right value because a little bit stronger and everything collapses into a singularity, and the universe never expands. A little bit weaker, the universe expands so rapidly and that it's just an endless cloud of disorganized dust. But in either case, too weak or too strong, you get no planets, no life, and you know what? No us, John.
So I guess it was good luck for us that gravity turned out the way it did.
Well, luck, maybe, but what if there were actually zillions of universes, each with a different value for the fundamental constants? What if that were so?
Oh, it'd be like a bingo game where they kept going till everybody got bingo. The existence of stars and planets wouldn't be a matter of luck at all. It would be a matter of statistics.
Exactly right, because given enough universes, just as you said with the bingo analogy, there's sure to be one that goes bingo, hospitable to life.
Well, that's a clever argument. It seems kind of, what's the word? Philosophical or maybe speculative?
You'd prefer to believe in intelligent design, maybe?
Well, that sounds nice, but why does that come up?
Well, because if you don't think life is an accident, it's the only other hypothesis that actually explains why the universe is hospitable to life and non-accidentally so. Anything else, if you don't accept the multiverse and you don't accept the intelligent design, it just reduces life to a lucky accident. And you know, science, John, and not just speculation, science abhors accidents.
Well, Hume said the most likely hypothesis was that the cause or causes of order in the universe bear some remote analogy to human intelligence. So I shouldn't be snarky about intelligent design, although, you know, Darwin seems to have changed things a little bit. But before I buy into the multiverse as an attractive option, I'd like to see some experiments or observations or data to go on.
What do you want? You want like a collision between universes? Would that be enough to convince you?
I think it would convince me, but not for long because because I'd be gone. But besides, you're talking science fiction.
I don't know. Science facts can be pretty strange sometimes stranger even than science fiction.
Well, to help us separate science fact from science fiction, we sent our roving philosophical reporter, Shuka Kalantari, to speak to a sci-fi author about parallel universes, and then to check with a philosopher of physics to see what science says. She files this report.
We were wondering if you had time to talk.
We have some questions.
A lot of questions.
You guys have been thinking about Hugh Everett's many worlds interpretation, haven't you?
Hugh Everett proposed the many worlds theory of quantum mechanics back in 1957. It's the idea that particles can be in more than one state or place at the same time. When we measure these particles, or have them all come together into an event, like opening a door or sitting down in a chair, those states actually collapse into the reality we experience, our reality. But what about all the other universes? Scientists and philosophers love to speculate, as do television producers.
Most of us experience life as a linear progression. But this is an illusion because every day life presents us with an array of choices. And each choice leads to a new path. And in each choice we take creates a new reality. Do you understand?
Yes, but what does it have to do with déjà vu?
Déjà vu is simply a momentary glimpse to the other side.
That's from the old TV show Fringe. There's also the cartoon Family Guy. They love to have fun with the multiverse.
God, this place looks terrible. Looks like Quahog was vaporized or something.
It says that in this universe, Frank Sinatra was never born, and therefore he was unable to use his influence to get Kennedy elected. So Nixon won the 1960 election and totally botched the Cuban Missile Crisis, causing World War III.
We also have depictions of the multiverse in shows like Stranger Things, Tron, and The Twilight Zone. The list goes on. And there's a ton of science fiction novels about parallel universes, because the idea of other worlds is exciting.
We only get one life. We only experience one single path of reality.
David Walton is a science fiction novelist.
And the idea of imagining, well, how might things have been different in my life? What if I had chosen a different school or a different partner? How much different would my life have been? How much power do my choices really have in defining my life?
That's more or less the foundation of Walton's novel, Superposition.
Superposition is about a quantum physicist who is unjustly accused of his colleague's murder.
And he needs to find out who the real murderer is.
The main character ends up being in two places at the same time.
In a quantum superposition.
So he is both captured by the police and put on trial for this murder, and at the same time he is on the run, trying to figure out what happened to put him in this situation and what actually happened with the technology to get his colleague killed.
He's living in two parallel worlds at the same time.
Yes, there are these alternative worlds that are occurring at the same time but closed off from one another. Yes, that could happen.
Janan Ishmael teaches the philosophy of physics at the University of Arizona. She says the sci-fi author's storyline is technically possible according to Hugh Everett's theory of many worlds.
That's always one of the questions in the Everett universe, is how to describe the relationship between the people on these different branches of the wave function.
Ishmael says in one sense, the character in Walton's novel is two different people with two different histories.
But in another sense, they are the same people because they share a common segment of their own past. Because at one time there was only one person there and then it branched into two.
Philosopher Janan Ishmael believes in the many worlds theory and the possibility that there are many different versions of us. In fact, she teaches about it at the University of Arizona. Science fiction author David Walton may write about the multiverse, but he thinks the theory is one big cop-out, a desire for scientists to prove that our universe isn't special, that there is no divine intelligence, no God. Walton is a one universe, one God kind of guy. But in the end, both agree that we have to do the science, do the math, and fill in the gaps in space and time from there. For Philosophy Talk, I'm Shuka Kalantari.
Thanks, Shuka, for bringing us up to date about science and about science fiction. I'm John Perry. With me is my fellow Stanford philosopher, Ken Taylor.
And today we're thinking about the mystery of the multiverse. Joining us from South Africa is George Ellis, where he's a distinguished professor of complex systems at the University of Cape Town. He's author of How Can Physics Underlie the Mind? Top-Down Causation in the Human Context. George, welcome back to Philosophy Talk. You were with us a long time ago, and welcome back.
Indeed. Thank you very much for having me.
So George, in addition to the book Ken just mentioned, you've published a book that you wrote with Stephen
Hawking.
Stephen Hawking, I'm sorry. My mind is moving slow in this world. Called The Large-Scale Structure of Space-Time. I detect an interest in really big things. Other physicists like really small things. They worry about whether a quark is charming or not. But you're interested in the really big things like the universe as a whole. How come?
Well, I ended up at Cambridge in a group that was a very, very strong group. It was led by Dennis Sciama. We had with us Stephen Hawking, Martin Rees, and various others. And it was the topic that the group was looking at the time, which was a time when there was a huge flowering of understanding of general relativity theory and of the theories of the start of the universe and so on. So I was lucky to be at the place at that time when, the theory was coming to fruition.
So you've written a lot about different lines of thought that all lead to the hypothesis of a multiverse. And it seems to me you're pretty skeptical about all of them. But among those, what's the most plausible theory?
The most plausible theory of the universe, we need to be quite clear if we're going to be talking physics or if we're going to be talking philosophy. And I'm happy to put on either of those hats. In terms of physics, it's perfectly possible that there is one universe. It's a universe which has very special values, and that's it. There's nothing more to say about it. So you can use your inductive reasoning, as we've already been told, to suggest that there should be the multiverse, but that's a philosophical position, and it's not testable, as we have already been mentioned, or we could discuss further. So from the viewpoint of a physicist, you don't have a drive to go for the multiverse except for one possible thing. We do understand to some degree the physics which underlies the expansion of the universe with very, very early times. And we've got various theories about that, and some of those theories lead to a multiverse and some of them don't. The problem is we can't test between those theories. And so I can say that physics that we know isn't testable and does not lead to the prediction that there is a multiverse. I can say I understand that you can have hypothetical physics which leads to the multiverse, but I'm unimpressed by that. I want something which is testable.
Well, we're going to have to dig into that, because I'm not sure I buy your distinction between philosophy and physics as if there's a neat dividing line, and you can clearly separate out a philosophical argument from a scientific argument. So we have to dig into that a bit.
But these theories are the result of physicists. Philosophers aren't smart enough to come up with them. But now we're going to go to a break.
Yes, you're listening to Philosophy Talk. Today we're thinking about the mystery of the multiverse with George Ellis from the University of Cape Town in South Africa.
Can there really be any scientific evidence for a multiverse? We'll dig further into that topic that just came up in our next segment.
The universe versus the multiverse, the smackdown. Plus your calls and emails when Philosophy Talk continues.
How many worlds will we ever see? And how many people can we ever be? If we wake up.
We've only seen one world. At least I've only seen one world. Well, maybe I need better glasses. If the multiverse is real, there may be a lot of them out there. I'm John Perry. This is Philosophy Talk, the program that questions everything.
Except your intelligence. I'm Ken Taylor. We're thinking about the theory of parallel universes, the multiverse.
Our guest today is George Ellis from Cape Town, South Africa. He's the author of How Physics Underlies the Mind and lots of other things.
So, George, I want to kind of press you a little bit on something you said in passing. You said there's no scientific drive and there's no physical drive. I mean, philosophers get carried away with this stuff, but I think of the people who has originated the multiverse hypothesis as physicists, and maybe not so much cosmologists, but go back to the Everett interpretation of quantum mechanics and the collapse of the wave function. What happened to some determinate state? What happens to all these other states? Well, they happen in some alternative reality. They all happen, right? All the possible outcomes, that superposition kind of precipitates out into a position. So there's Schrodinger's cat, right? All that kind of stuff. So that's not philosophy. That's you physicists. So isn't there? And plus, there's the where do the values of these fundamental constants come from? That's not philosophy. That's physics wondering about that.
Those are two different arguments, right?
Yeah, those are two different arguments. But so isn't there a physical drive that drives you to the multiverse?
Well, let's take these two separately. As to the Everett multiverse, I'm one of the people who believes there is a collapse of the wave function. The wave function doesn't split in the wave that Jenin was talking about it, and so there is only one path which takes place. There's a huge number of potential paths. Collapse of the wave function takes place, a specific one happens, and that's it. And so I just don't believe that Everett interpretation.
Well, but the question. But I know lots of people don't believe it. But the question is, that's a purely physics-driven hypothesis, right? That's not just philosophical speculation.
It's philosophical in the sense that there isn't any experiment which can separate out the Everett interpretation from the standard one. And so you can choose to do either. There isn't any experiment, and so in my book, that's philosophy.
Well, you sound like your views are exactly the views I would have, even though I wouldn't understand them nearly as well. But we kind of need you to defend your fellow physicists here a little bit. I mean, I take it these are mathematically coherent theories that have something philosophical going for them, that these physicists in their philosophical moments must like something about them. They must make the universe seem more rational. And we'd like to understand what in the world that is.
Okay, well, if we keep on the Everett one, the basic thing is that we've got Schrodinger's equation, which predicts the evolution of the wave function. What the wave function does, it gives you probabilities of outcomes of experiments. And a lot of physicists stick to the Schrödinger equation, and they deduced from the Schrödinger equation that the multiverse occurs. However, there's an additional thing which happens in physics, which is a measurement takes place. When a measurement takes place, collapse of the wave function takes place, and that multiple branching is collapsed into one particular specific outcome, and that's when the classical world emerges from the quantum world. So my view on this is like Roger Penrose very much. And so the point I would make here is there are equations one can use to describe the universe, but you've just got to work out which equation is the right equation to use at any particular time. And in my view, it's a mistake to keep using the Schrödinger equation at all times. It's valid for a while, and then it stops being valid when collapse of the wave function takes place.
So let me just try to get a little. So we've got Schrödinger's cat, which, in case people don't know, you put a cat in a box with some with a Geiger counter or something, and at some point it either does or does not, based upon the completely quantum events that it's measuring, release poisonous gas. And then, you know, when you open the box, the cat's either alive or dead. So did it? Was it indeterminate? Now, on some people's view, it's indeterminate. It's the observation that collapses the wave function, which seems kind of magical. I think on Penrose, it's something that he finds deep in quantum mechanics that collapses it. So the cat really would be alive or dead whether we looked in there or not. Is that your view?
Well, in my view, it's a mistake to talk about the wave function of the cat. In my view, quantum physics applies at microphysics, not at the macrophysical level. I don't think the wave function of the cat makes any sense. I think where the wave function exists is in there's an excited atom which is going to decay. That's where the wave function exists. That's where the uncertainty exists, but not for the cat itself.
But I'm going to try and take you back to the where the values of the fundamental constants kind of come from. I mean, I think it's tell me if I'm wrong. I think it's a scientific drive. I think you could think several different things. One thing you could think is that at the bottom of the universe, at the very foundation of it, is just a big fact. The gravitational constant is X. The speed of light is Y. Planck's constant is Z. That's just a fact. There's no further explanation. Science wants to get to the ultimate explanation. Even religion wants to get to the ultimate explanation. Common sense wants to get to the ultimate explanation. There's an explanatory drive that's going to say, I'm not going to posit an accident unless I'm absolutely forced to. I'm not going to posit a brute fact unless I'm absolutely forced to. One of the ways you could get to the multiverse hypothesis is saying, well, that brute fact isn't satisfactory, isn't explanatorily satisfactory, whether that's driven by a scientific urge or a philosophical urge or a common sense urge.
Yeah, well, what you've said is a perfectly good philosophical argument. Part of the problem is that we don't know which are the fundamental constants in physics, how many of them are, and how they're related to each other. That's a very, very deep kind of subject. But the key point, which you've made earlier, only some of those constants allow life to exist. And in the end, there are these two options, that they just have the values they have because they allow life to exist, or there is the multiverse out there with zillions of different values of the constants, and somewhere or other life it'll work out right for life to come into being. Now, in order for that to happen, you've got to have a mechanism which creates lots of bubble universes out there which are similar to ours, but they've also got to make the values of the constants of physics different than the values in our bubble. There are reasonable theories of how it works to create the different bubbles, but the theories about why there should be different constants of physics in those bubbles are really very, very speculative. I would call them Rube Goldberg contraptions. They are not natural in any sense. But the further key point is you're talking here about hypothetical physics. None of this is tested physics. The physics which is alleged to lead to the bubbles is not tested physics, and the physics which is alleged to lead to the various values of the constants isn't tested physics either. And that's why it's philosophy.
You're listening to Philosophy Talk. We're talking about the multiverse. Richard in Richmond. That's alliteration.
Yes,
welcome to Philosophy Talk, Richard in Richmond. What's your comment or question?
Yeah, I just had a comment to make. Coincidentally, I had been auditing Brian Greene's The Hidden Reality, which talks about string theory and the multiverse and those theories. And an explanation, which I hope I can repeat accurately, which seemed to explain things to me, started with the phenomenon that the Earth is 93 million miles from the sun, which is perfect for life, and how did that happen? And he uses a shoe store by analogy to explain the reason or logic behind concluding there must be multiverse at work. And that is, you walk into a shoe store, you need size 7, and bingo, they have size 7. You think, oh my gosh, what a coincidence. Well, it's not a coincidence because the shoe store has every possible size, and so that, I don't know if this is an accurate recapitulation of what he said, but it made me understand that it's sort of like a Schrodinger's cat or a quantum uncertainty type principle, that it must be that there are almost infinite numbers of variations there for our world to occur if you're using scientific analysis to explain the way our universe is. So that was my comment. I hope I got it right, but maybe one of your panelists can correct me. Or
well, the one who could is George. And thanks for the call, Richard and Richmond. So what do you think, George?
Yeah, I think that's a very nice description of the way it goes. And there are multiverses that are like that. There are also multiverses in which the right size doesn't exist in any of the universes, you see.
Yes.
And so having a multiverse theory by itself doesn't solve it. It has to be a specific kind of multiverse. And so the real issue is that you have to have a special universe for life to exist. But then if you go up one level and you explain it by the multiverse, you have to have a special multiverse in order that they exist within the multiverse, a universe with the right kind of things to happen. And so all you do is you shift the problem up one level. You don't solve it.
Well, you got to be careful as a physicist. People aren't going to realize you're being a little bit sarcastic, and they're going to say, "Oh, here's the Ellis hypothesis. We got a multiverse."
Right. But
some philosopher would do that.
So, George, I want to ask you something else, though, because you said this is not science. I read somewhere. Somebody claimed I read one of the believers in the multiverse responding to an article of yours that I think was in Scientific American, that, well, it is science, but it's kind of post-empirical science. And he said that not as a term of derision. And I think there's something, what I mean by that is I think there's something serious here. Look, I have a theory, like string theory, or quantum mechanics, that has certain kind of open questions to it, predicts something, right? So there's this wave function, there's this probabilistic thing, and then there's actually determinate states. And the theory has no kind. It kind of predicts the possibility from the stuff that we've confirmed. You know, maybe we can't directly confirm this, but this theory that we confirm in other ways predicts certain other possibilities, and we believe in those possibilities on the basis of the well-confirmed theory that allows for those possibilities. Why not? I mean, it's like that a lot, isn't it?
Well, I mean, post-empirical science. Well, no, we already have some mathematics, which a lot of people think is not empirical, but that seems to just tell us about possibilities. It doesn't tell us which one is there. But I'll turn it over to
so what do you think
Professor Ellis
about post-empirical science and believing stuff on the basis the theory predicts it, even though you can't confirm it, but the theory is otherwise confirmed. Other parts of the theory are confirmed.
Well, we had a big meeting about this in Munich last year, and I believe that pushing post-empirical science is a very strong threat to the very foundations of science. I don't think it's a great way to go. When you've got climate deniers and all the rest of it out there, you've got people questioning vaccines and all the rest, you do not want the foundations of science to be undermined by people talking about post-empirical science. And this could be a whole topic in its own right. As far as the multiverse itself is concerned, you've got physics, which is great tested physics, and it predicts the way the universe expands. But as you go back to earlier and earlier times, you get to the parts of physics which you haven't been able to test in a laboratory because the energy is higher and higher. It's energies which you can't test in colliders on Earth, and that's when it starts getting hypothetical. And you can project from what we know, you can extrapolate to potential physics, and some of those potential physics extrapolations predict the multiverse, some of them don't. And it's the fact that you've made that extrapolation which is where it moves from tested to untested physics. So it's that extrapolation business, which is why I say that this isn't a proper scientific theory. It's good scientifically based exploration. It's a good philosophical explanation of the outcomes of potential science, but it's not established science.
Okay, I think maybe we have a meeting of the minds, and maybe there's a crisis in physics. I'm not sure which. Whether there's a meeting of the minds or a crisis, it seems how you frame this. In one way, it doesn't bother me that this thing called post-empirical science is actually what philosophy does. It's like physics and philosophy meeting at the limits of inquiry, where physics ends, there's still some open questions, and philosophy thinks, well, it could be like this, it could be like that, it could be like that. And that's consistent with our physical theories in some way. And the scientist comes along and says, yeah, but where's the data? Where's the test? Where's the experiment? Okay, I get that. But it also sounds like there could be a crisis in science. That is, you guys have reached the limits of the scientific method in a certain way. These questions just boggle science. Is there a multiverse or a single universe, right? Does the wave function collapse, or is the ever? I mean, you guys have just reached the limits of that, and there's no going beyond the limit, right? And you're kind of in a crisis about what to. You're kind of in a crisis in a little bit about what to do, and you're divided about what to do.
Well, there are some parts of science which are fantastically well established, but when you push it to the very boundaries, and so, for instance, we don't have a well-established theory of the origin of the universe, and we never will have, because you can never test what happened at the start of the universe. It's beyond testing. And so you can have wonderful theories. You can test the outcomes of those theories. The problem is, in order for it to give a really definite scientific theory which you can say is tested, there must only be one theory which is possible. You've got to show that all the alternatives can't happen.
So I just mentioned there's one practical threat to non-empirical science is that post-empirical science. Yeah, I mean universities may get enthused about this because it would be so much easier to fund than the kind of science that requires laboratories and stuff. And they could move it into some old dilapidated building like they do with their philosophy department.
No, but they couldn't do that because you can't do post-empirical science well unless you get to the limits of empirical.
I see. Okay, so. I have another question here. In the intro, Ken and I were kind of saying with respect to this one kind of multiverse, the one that has to do with the fundamental constants, that there seem to be two explanations. One option is no explanation. Then there's the multiverse explanation. And then there's the intelligent design explanation. But given that we're over on the philosophical side of things, isn't there another possibility, and isn't it one you've talked about, that a kind of a top-down explanation, not an explanation from some kind of godly mind, but just an explanation from some kind of fundamental thing that we need to take to be important to the universe that comes from the top down and not the bottom up?
I think the nature of causation in the universe is crucial, and most physicists take it just to be in a bottom-up way, that, for instance, what's happening in my mind is determined by the interactions of electrons and protons in my brain. And it's crucial in looking at the big picture of the universe to see that's not the only kind of causation that takes place. In addition, there is top-down causation. For instance, I'm talking English at the moment, and the reason I'm talking English is my society taught me to talk English and shape the connections in my brain. What this is to do with is how complexity arises in the universe, and in a sense that's one of the key issues which is being brought up in the multiverse discussion. And this comes in when you've got the constants of physics which allow complexity to occur, but the question is, how does the complexity come into existence? And in that context, a certain amount of stuff can grow by self-aggregation, by just natural processes of accretion. But there's a limit. There's a limit to the complexity that come into existence in that way, and that limit comes when you have to start getting adaptive selection taking place so that Darwinian processes can come to start. And the core of a Darwinian process is that the environment feeds information into the organism and says, this is the environment, you'd better adapt. And that's a top-down process from the environment into the structure and behavior of the organism. And so where that comes in is how complexity arises once you've got the constants of physics right for that to take place.
George, we'll have to dig into this further in our final segment. You're listening to Philosophy Talk. We're thinking about the mystery of the multiverse with George Ellis from the University of Cape Town in South Africa.
In our next segment, we're going to focus on our finely tuned, relatively friendly universe. Is it the friendliest one we could hope for? And what is this friendliness evidence for? Luck, a multiverse, intelligent design, or something deeper having to do with the nature of causation?
Where did the friendly universe come from? When Philosophy Talk continues.
Could any world, another universe actually be better than ours? Could life as we know it exist in a parallel universe? I'm John Perry, and this is Philosophy Talk, the program that questions everything.
Almost. Except your intelligence. I'm Ken Taylor. We're thinking about parallel universe. Our guest is George Ellis from the University of Cape Town in South Africa.
So, George, in a situation in which there's no experimental or empirical evidence to be had, isn't the truth path of science to turn the issue over to philosophers or even theologians?
I think it's very important that scientists realize the limit of science and indeed at that point say this is the limit of science and yes, we need to turn over to philosophers. I think that's absolutely correct.
But can we get... Okay, so the question would be, science tries to give us compelling bases for our beliefs. Once you get to theology and philosophy, you can have reasons for your beliefs, but can they compel you? So it's not... Can philosophy or theology settle this question of whether... there could be a multiverse out there, and we could just lack the scientific means to know it. Can philosophy and theology actually fill the gap between what science can teach us and,
Well, they can't compel you to do it, but they can give you reasons which you can find convincing, and other people will find other reasons convincing. But let me just make a thing which is a very point which I think is very important, and that is what kind of data do you take into account when you're making these arguments? Now, my scientific friends quite rightly take data into account you get from telescopes, laboratory experiments, from microscopes, from repeatable experiments, and they restrict their investigations into this cases where you can get strictly repeatable results, and they get incredibly predictable behavior of matter. They discover that out of those incredibly predictable results. If you notice what has happened there, they have got those incredibly predictable results by excluding anything to do with meaning or emotion or beauty or love or joy or hate, any of those kind of things. Now, that is a perfectly acceptable thing. But what is very odd is if you then write a book or an article and you say there is no meaning in the universe. You have obtained that position by deliberately excluding from your consideration all of the data that would have led you to conclude that there is meaning in the universe. And so this is where philosophy is very important, is to say, let's look at the kind of data which has been taken into account and the kind of inclusions that are coming out. And if you only look at the immaterial stuff, of course you conclude there's no meaning in the universe. If you look at the stuff which deals with meaning, Shakespeare, Dostoevsky, Gandhi, Mahatma, Martin Luther King, a whole lot of stuff there, you will conclude conclusively there is meaning in the universe.
So George, you're very much of back to your top-down causation thing.
Yeah.
You're very, very sincere about this kind of what I'm going to call an anti-reductionism, because, see, the reductive philosopher, like me, thinks, yes, so there's meaning in the universe, but it's a mystery how we get there. We have to start at the bottom and see how by organizing things at the bottom, collections of fundamental things in the right way and evolving them, the meaning could emerge out of the mere workings of the bottom. And it sounds like you kind of refuse to accept that as the only legitimate way to think about the reality of meaning in the universe.
Correct. I think that there is meaning and that it does emerge, but once it's emerged, you've got these levels of structure. You've got the atomic level, the molecular level, the cellular level, the organismic level, the level of the whole organism. There is meaning and there is causation at each of these levels, and there is valid causation which occurs at the level of the mind, which it's enabled by the underlying physics, but the physics doesn't determine what happens. The mind itself is what determines what happens according to the logic which works at the level of the mind and rational thought.
So we got a couple of emails here, and we got a caller. I'll take the caller, and then, John, you can do the emails, okay? So Keith in San Francisco, welcome to Philosophy Talk.
Thank you. I'd like to discuss, or have the guest discuss, the idea that if the theory behind quantum computing is proven to result in a working quantum computer, that is a justification for the multiple universe theory.
Oh, wow. That's an interesting one, Keith. From quantum computing to the justification of the multiverse. Can you really get from there to there?
David Deutsch, who is one of the founders of quantum computing, believes that that is the case, but many other people working in quantum computing do not believe that that is the case.
And George Ellis believes?
Sorry?
And George Ellis believes?
No, I don't believe it is the case. I believe that a particular quantum computer, it's got these superpositions, and if you want to talk about them happening in parallel, they do happen in parallel, but at a particular point, when you get an output from the computer, when it prints an output on the screen, you have collapsed it. It's no longer parallel universes, and it's no longer parallel wave parts of the wave function, and a specific outcome comes, and the Everett interpretation doesn't apply.
Yeah. So you want to look at one of
those?
Yeah,
we've got 2 emails. Both recommend books. I think I'll read or at least summarize them both. The first is from Tim, who says, I want to give a shout-out to a book I recently read called Dark Matter by Blake Crouch. In it, you get to live with a protagonist who's able to travel between multiverses. Multiverses that maintain the same physics, however. It's quite a wild ride, he says, big fun, but it produces a headache. The second is from Carl, and he gives a shout-out to a book by Tim Mulligan, Purpose in the Universe, in which he gives atheists and theists their due with regard to their arguments. And he says it's compelling and well argued and seems to agree with pretty much what George Ellis is arguing for. Either of you two heard of or read either of those books?
Not me.
No, I haven't, but the second one sounds great.
George, I want to ask you something else. Speaking of something that was said in those 2 emails, so as I understand it, there are many different ways the multiverse might go. Some less strange than others. So it could just be that there's one single huge space-time. I assume you believe that there's an unobservable universe. There's the observable universe and there is the unobservable universe, right?
All that dark matter and stuff.
There's quite a lot of the universe which is unobservable. Dark matter is not observable.
Right.
But the biggest problem is that the universe is only 13.87 billion years old. What that means is, crudely speaking, we can only see out to 13.87 billion light years. Now, that's a huge distance, but nevertheless, we can't see anything beyond it by any kind of radiation of any sort.
Right.
Telescopes are no help. And so I can say anything I want to about what is beyond there. You can say anything you want to, and there's absolutely no way to disprove it.
That's true. But it's possible, and there might be a theory that predicts the reality that way out there, way beyond, in the same kind of space-time continuum, but at a spatial separation from us, there's like another universe that bubbled up, right, because of infinite expansion or something like that. I mean, that's a coherent theory, right?
Yes, there are coherent theories exactly of that kind, and the problem is they depend on specific physics, and that physics isn't testable for the reasons I've already said. And so those are perfectly good hypotheses. They're scientific theories, but in the end, they're not they aren't testable science, or they're certainly not tested science.
So you mentioned Roger Penrose a bit ago, and I've made some kind of feeble attempts to understand Penrose, and it's quite fascinating, but it reminded me of what a lot of philosophers over the years have thought, that the concept of matter is very distorting, that there's a basic activity to what's fundamental in the world, and you even find this at quantum physics, and it seemed to me that he was thinking that there was a little bit of value or meaning even at that level, that is, something is trying to be preserved by the tiniest things or the tiniest activities in matter. Am I totally misreading him, or has he got this top-down concept in his view a little bit?
I don't think he does. I don't think he talks about values. He talks about losing time as the universe expands, because massive particles decay and only massless particles remain. And he has a version of the multiverse, which is a version in time, in which the universe repeats endlessly in time, and various other people have such. So that's a completely different one.
Right. Let me ask you one last question. We're getting to the bottom. So you've been skeptical about these things. You say they're kind of coherent and there can be philosophical. Can you imagine? Nobody's thought of a way to test string theory, I take it, which, but can you imagine that these things becoming testable, or is there some in principle bar to their testability?
There are two possible tests of some multiverse theories. The one you've mentioned, which would be bubble collisions, different multiverses collide, which in principle we might be able to see. So if you were to see that, I would find that as beginning to provide evidence which would make me think maybe it could be true. But on the other hand, the problem is, if you never see such collisions, then they'll just say, well, we live in a multiverse where collisions don't happen, and so it doesn't lead you there. Yeah. The other thing is, on the other side, it's possible that we live in a universe in which the universe is closed on a spatial scale. Let's say you head out sideways at 10 billion light years, you end up back where you started. Just like in one of those video games, you go off the one side of the screen and you come back the other side. It's possible we live in such a universe in which we see around the universe since the time I mentioned, the 13.87 billion years ago. In that case, we would have seen everything which exists already, and then we would have proved a multiverse doesn't exist. Now, people have tried this and they have failed to prove it. Well, so that could be a disproof, but it hasn't worked so far. But if it doesn't work, it doesn't get you either way. But if it would be a disproof of a particular, if it was true.
Well, George, on that note, I'm going to have to thank you for joining us. This has been a fascinating, multivarious conversation.
Thank you very much for having me.
Our guest has been George Ellis. He's a distinguished professor of complex systems at the University of Cape Town in South Africa. He's an author of How Can Physics Underlie the Mind? Top-Down Causation in the Human Context. Now, this conversation continues on our website at Philosopher's Corner and our online community thinkers, where our motto is cogito ergo blogo. I think, therefore I blog. And you too can become a partner in that community. All you have to do is visit that website, philosophytalk.org, and once you're there, you can get the access to the entire past archive of Philosophy Talk just by becoming a partner.
Now, somewhere in the multiverse, I'll wager, this guy talks even faster than he does here. It's Ian Scholes, the 60-second philosopher.
Ian Scholes, I hate to break it to you, but the whole multiverse thing is just hypothetical. Thought experiments. And the multiverse umbrella, of course, covers a number of universes, the alternate universe, the parallel universe, or merely just, other universes, like neighbors who didn't really recently move in. It just took this long for the speed of light to find them. Some scolds worry that since we can't really verify the multiverse through scientific methods, any speculation about it could damage the study of physics and erode public confidence in science, the way voting erodes confidence in our political system. Also, how can you disprove a theory of the multiverse when that theory, theoretically, could also include a multiverse where the multiverse doesn't exist? Well, the speculation about other universes might be just kicky fun. So what? The study of astrology didn't really kill astronomy, I don't think. There might even be an alternate universe where Libras are better decision makers. And how are we going to know how to kill vampires if science does not speculate? Where would Star Trek, for one, have been without alternate universe to land in occasionally? I remember one in particular that involved the Enterprise gang joining up with Abraham Lincoln to battle giant potatoes. Without modern physics, that storyline would not have been possible. There are theories that matter is finite, yet universe is infinite, kind of like numbers or the alphabet. There's a theory held by Elon Musk, I believe, that the universe is nothing but a big illusion, a computer-generated program, which raises the question, where's the computer? Who did the coding? To those who invoke other universes that we can't see to explain mysteries in this one, well, why not just say God? Of course, God could exist and not exist at the same time if we buy the ultimate multiverse theory, which contains every mathematically possible universe under different laws of physics. It could even contain an exact duplicate of this universe, one in which I'm speaking on an exact duplicate of this very microphone. Then there's the brain theory, B-R-A-N-E, which holds that the universe is a brain, that is, the equivalent of a dot. In a one-dimensional world, our universe is that dot in a multidimensional world of infinite universes. Multiverse theories don't seem to dwell much on the poetic side of things, the Robert Frost alternate universe, the road not taken. But, of course, there's probably a universe where every road is taken, all the children are above average, where even a Trump can run for president, where I married the Keno girl I saw across the casino floor in Reno back in 1978. Was I even in Reno in 1978? And there's a universe where blimps still glide across the sky, where baby Hitler was murdered in his sleep, Uncle Bernie is king of the world, and my 6 grown children are all highly successful recording artists living together in a big treehouse in Washington State. They send me checks. Thank you, physics, for the life I could have had, the glorious life I thought I desired. All there, all mine. And it all fits in the back of that giant turtle swimming in the ocean of infinity. I just read a story about a guy, high on LSD and cough syrup, who was found clutching a dog, heroically, outside an apartment building he apparently thought was on fire, from which he had rescued the dog. Ha ha ha, thought the firemen and the media. But what if, in his LSD-induced hallucination, he had entered an alternate universe where he actually had rescued a dog from a fire? If true, it would throw everything we know about the universe into a cocked hat, which would also be real and infinite. It's probably amazing. Theoretically. I gotta go.
Philosophy Talk is a presentation of Ben Manila Productions and the trustees of Leland Stanford Junior University. Copyright 2016.
Our executive producer is David Demarest.
The program is produced by Devin Strolovich. Laura McGuire is our Director of Research. Dave McAllister is our Director of Marketing.
Thanks also to Merle Kessler, Mark Stone, Erica Topete, and Colin Peden.
Support for Philosophy Talk comes from various groups at Stanford University and the partners at our online community of thinkers.
And also from the members of KALW San Francisco, where our program originates.
The views expressed or misexpressed on this program do not necessarily represent the opinions of Stanford University or of our other funders.
Not even when they're true and reasonable. The conversation continues on our website, philosophytalk.org, where you too can become a partner in our community of thinkers.
I'm John Perry.
And I'm Ken Taylor. Thank you for listening.
And thank you for thinking.
It just occurred to me, if there are an infinite number of parallel universes, in one of them, there's probably a Sheldon who doesn't believe parallel universes exist.